Imagine you're running a popular online game or an e-commerce platform. Suddenly, a flash sale or a viral moment drives thousands, maybe millions of users to your servers at once. Some servers get crashed under the load, while others are barely touched. Requests slow down, pages fail to load, users get frustrated. Performance isn't just about raw speed, it's about keeping your system responsive, reliable, and capable of handling unpredictable traffic. In this video, we'll explore how modern systems handle massive loads, optimize latency, and distribute traffic efficiently. And by the end of this video, you will understand the techniques that keep large-scale applications snappy and reliable. So let's get started. The first step in handling heavy traffic is load balancing. Think of it as a traffic director for incoming requests. At a high level, there are two main types. Layer 4 load balancing, which works at the transport layer, TCP/UDP. It decides where to send requests based on IP addresses and ports. Its pros are that it is fast and has low overhead, while its con is that it doesn't know anything about the content of the request. Now let's talk about layer 4 load balancing. It works at the application layer, HTTP/HTTPS, and can inspect URLs, headers, cookies, or even request content. Its pros is that it can do smart routing, which means that it can send and receive all image requests to specialized servers, but it has slightly more overhead than layer 4. An example can be that a news site can route video requests to a social media server and an API request to a different backend, all automatically. Sometimes user needs to stick to the same server. Imagine adding items to a shopping cart. If your requests go to different servers, your cart might disappear. This is called sticky session or session affinity. But what if users are spread globally? Sending everyone to the same data center increases latency and can overload servers. Geo-distributed load balancing solves this by routing users to the closest available server, reducing network delays, and improving response time and user experience. Example, a user in New York gets served from a New York data center, while someone in London gets routed to a European server. Before optimizing, you need to know where the system slowed down. Profiling lets you measure which database queries are taking too long, which endpoints are slow, or where CPU or memory uses spikes. So how is profiling done? Code Profiler. It measures how long each function or method takes to run. Database Profiling. Log slow queries and check execution plans. Application Monitoring. Track API request times and CPU or memory uses. You might discover that a single poorly optimized query is slowing down thousands of requests. Fixing that one query can dramatically improve performance. Once bottlenecks are identified, multiple strategies can reduce latency. First is batching, combining multiple requests into one to reduce round trips. Another is compression, reducing the size of data sent over the network. Example, we can compress JSON responses or images to save bandwidth. Caching, storing frequently accessed content closer to users. Example, a CDN like Cloudflare serves static assets from servers near the user. Edge computing, move computation closer to the user instead of relying on a centralized server. These techniques shave off precious milliseconds, improving both speed and scalability. Putting it all together, performance, load balancing, and latency optimization are closely interconnected. Load balancing ensures that no server is overwhelmed. Profiling tells you where the delays are hiding, while latency optimizations make the responses fast and efficient. The result, systems are scalable, resilient, and responsive even under massive traffic spikes. We have now covered how to handle traffic and optimize latency, but modern applications often consist of many independent services. This brings a new challenge. How do services discover each other, communicate efficiently, and scale independently? In the next video, we'll dive into microservice and service-oriented architecture, exploring service discovery, API gateways, and interconnection communication platforms. See you there.